Hi, my name is Kristen Copeland, and today I'll be speaking on the ins and outs of honey making. Apis mellifera, also known as honeybees, forage nectar to bring back to the hive. We know that the nectar is dehydrated to make honey, but the process is much more complicated. If you have ever tried to taste nectar, you know that it isn't nearly as sweet and tasty as honey. So, what chemical and physical changes does nectar go through to become honey? First, let's begin with the chemical makeup. Nectar is an aqueous solution containing mainly 3 compounds, all of which are sugars. The largest of these 3 is sucrose. Sucrose is the most abundant sugar in raw nectar. The other 2 compounds in the solution are fructose and glucose. There are very small amounts of fructose and glucose in raw nectar. You may have noticed that glucose and fructose look very similar to the structures in sucrose. This is because sucrose is a massive molecule where one glucose molecule and one fructose molecule are bonded together. To me, sucrose looks like a glucose molecule and a fructose molecule are holding hands. An enzyme in a bee's saliva, invertase, acts as a catalyst and breaks the sucrose down into glucose and fructose. But where did the chemical reactions take place? The nectar collected by the forager begins to break down as soon as it comes into contact with the forager's saliva. While the forager is still collecting more nectar, the enzyme invertase will continue to break down the sucrose in the forager's honey stomach. Once the forager has filled up on nectar, she brings the nectar back to the hive where she will pass it on to another worker bee known as a processor bee. This exchange of nectar introduces more saliva into the mixture so more of the sucrose can be broken down. The processor bee will take the nectar to a cell where she will add more saliva and mix the nectar around to help the chemical reactions happen more efficiently. What exactly is changing within the nectar solution? Chemically, the ratio of sucrose, glucose, and fructose changes drastically. The average sample of nectar will be about 30% sucrose and 70% water with a very small amount of fructose, glucose, and other nutrients mixed in. In a study done on honey from Egypt, it was found that on average 39% of the honey was fructose, 31.5% of the honey was glucose, and only 3.5% of it is sucrose in the end. The rest of the honey is comprised of water and other nutrients. As the sucrose molecules are broken down, an important physical property changes: viscosity. The viscosity changes for a few reasons. While temperature and water content have a large impact on the viscosity also changes because the chemical makeup of the substance is changing. The viscosity of the solution increases as more of the sucrose is broken down. For me to explain this better, let's look at some data. These next few slides, I will be showing you some graphs regarding different sugar solutions and how their viscosity changes as the concentration of the sugar in the solution increases. On the left, we have glucose content percent in weight, and on the right, we have fructose. I have a line at 0.004 simply so we can see where the data points are landing relative to the viscosity axis. This graph is similar to the first two, however, this graph involves sucrose. Sucrose is the main ingredient in nectar, and nectar is mostly water and sucrose with a sprinkling of other compounds and nutrients. The horizontal line on this graph is located a bit higher at 0.006 millipascal seconds, or centipoise. As you can see, sucrose is a bit more viscous than glucose and fructose. On the left is the same graph that I had on the previous slide, but I wanted to have the sucrose graph next to the graph where the solution is equal parts sucrose, glucose, and fructose, because these mixtures can represent nectar before and after being turned into honey. Looking at the viscosities of each sugar mixture where the solution is 50% water and 50% sugar, we can see that the viscosity of glucose is 0.004 millipascal seconds. The viscosity of fructose is about 0.0047 millipascal seconds. The viscosity of sucrose is about 0.006 millipascal seconds. And the viscosity of the sucrose-glucose-fructose mixture is 0.0065 millipascal seconds. When comparing the individual viscosities, we see that glucose and fructose are less viscous than sucrose on their own, but when combined, the viscosity is much higher and has a higher exponential growth rate as the concentration of the mixture increases. Here we have an actual sample of honey being tested. I would like to preface that this graph and its data are completely unrelated to the previous studies, so the values are going to be a bit different. The composition of the solutions in the previous graphs did not involve any other components that would make natural honey thicker, like any dust or pollen. Looking at the graph, we have a density versus temperature line in gray and a viscosity versus temperature line in red. While this graph shows an exponential relationship between temperature and viscosity, you can expect a similar relationship to form between density and viscosity. In the figure, the density is increasing due to the temperature decreasing. However, if the density were to increase due to water evaporation, you would see a similar trend with the viscosity corresponding to the density. Of all the changes made to nectar, dehydration is the most well-known change. However, the methods may not be as well known. To generate heat, the bees will vibrate their abdomen rapidly. This heat helps the water evaporate from the honey. The bees will fan the open cells with their wings to push out the moist air out of the hive. Removing the moist air allows the honey to lose moisture to the air, even without the additional heat generated by the bees. The main points I want you to take away from this presentation is that honey is more than simple dehydration of nectar. Honey begins with nectar, a sugar solution comprised mostly of sucrose and water and a small amount of fructose and glucose. An enzyme, invertase, found in the saliva of a honeybee, breaks the sucrose down so the solution has a higher concentration of glucose and fructose. This chemical reaction contributes to the physical changes in the substance like viscosity. And the honey isn't done until the bees are happy. That concludes this presentation. Thank you for listening.